Hi, good morning. My name is Rose Fraley, and I'm going to be your tour guide here today at Elwood City Forge. We're very sorry that you're unable to be here in person to take this tour, but we're going to do our very best to give you an exciting tour and show you what we make here at Elwood City Forge. We're going to introduce you to some people on the shop floor, supervisors and workers. We're also going to take you into the offices to meet some people as well, so you could see exactly what people do here, and maybe that'll help you in your decision-making process as you go through school and decide what you want to be in the future. When you see me in the shop, I'm going to be wearing a hard hat, safety glasses, and ear protection because safety is very important here at Elwood City Forge. We want to make sure all of our employees come in and go home exactly the same in a safe manner. So without further ado, let's go on inside and take a look and see what's going on. So we decided to take a stop in the offices to give you an opportunity to meet Bill Nardone, who is our Vice President of Operations, and would like to say a few welcoming words.
Thanks, Rose.
Sure, Bill.
Welcome to Elwood City Forge. Each year, we offer opportunities for as many local high school students as we can accommodate to come into our facilities and look at some of the great job opportunities that we have at our facility. They offer 401ks, health care, bonuses, nice wages, and some really interesting work, all without the need for student loans. Unfortunately, this year we've had some difficult circumstances, as you're all aware, but we did not want to miss the opportunity to introduce these opportunities to as many of you as possible. So I hope you enjoy the tour. Rose.
Okay, everybody, let's go out in the shop and see what they're doing. Okay, so before we take you into the shop to show you our forging operation, we wanted to explain to you what forging actually is. When you hear our company name, Elwood City Forge, I'm sure you're wondering, what does forge mean? Well, forging is the process of taking two steel blocks and putting another block that's been heated to above 2,000 degrees Fahrenheit between it, and then you're basically smashing that hot piece and making it into a shape that the customer wants. Some of the shapes that we do forge are bars. So an application for bars would be in the aerospace industry. Another shape we make is a rectangular block. This would be used in the oil and gas industry. So we just wanted to give you an example before we go into the press booth next. We're going to actually show you a piece that's going to come out as a square, and the operator is actually going to forge it into a round piece. And you'll hear me explaining the process and what's going on as that's happening. See you there.
Welcome to our press booth at the Elwood City Forge. This is our operator, Joe Wright. He's the press operator for the day. As of right now, he's bringing out an ingot that was cogged down to an 18-inch square. He's going to grab the piece with our automatic manipulator that he operates. Everything that you see out there is automated and run by Joe while he's forging. Joe puts it on the die. He's going to straighten it out so he gets everything square, and he'll start forging between the dies. It's a 1,500-ton press. Those are the dies. Right now you see Joe cogging the piece down to a square, a smaller square. As he's cogging it down to a square, he's going to hit the corners of the square, which will turn it into an octagon. as you'll see here in a moment. As you can see, sitting in the corners, it's starting to look like an octagon. He'll cog down both ends and stretch the center out into a full elongated octagon. As it's cogged out, he'll run it through the swage dies, and the piece will end up as a 12-inch round, approximately 275 inches long. Now Joe's going to hand it off to the other nip on the other side of the press, and he'll do the same thing to the other side that he has done to this side already. Everything you see out there, both manipulators are all controlled by inside the press booth while Joe's forging. He operates everything out there, the wall cranes, the transfer buggies, the manipulators, the press. He controls everything from his little console right here.
Okay, so we're in the heat treat shop right now, and these are the bars that were just forged out the press, which leads us to our next operation that we do at Elwood City Forge. So they go into this big furnace right here to be heat treated. Heat treating is important because it's what makes the steel stronger to be able to use in oil and gas or in aerospace companies. So we actually have metallurgists on staff, and they determine the heat treat process that all of the forgings go through, and you'll get to hear from one later on in the tour. Okay, so now we're in the machine shop, and what we have here are bars that have been heat treated. You'll see they have a scaly surface to them, which is basically just iron and oxygen mixed together, and it's a hard type of surface. But we can't do anything with the bar yet until we test it. So you'll see this piece here where we've actually poured some steel out that we're going to remove test samples from. We'll also saw cut a slice off and then saw cut test samples out, which we have plates that we're going to show you as well. And then we perform different types of testing to show that the steel meets the customer's requirements. And once we can show that, then we're able to actually clean off all of this scale to the bright shiny stuff that's underneath and ship it to the customer. So let's go check out some of the testing techniques that we do. Okay, I'm standing here with Joy Bender. She's a testing lab coordinator, and we have some samples of saw cut test slices that have been cut out, and she's going to explain to you in more detail the testing process here at the test lab. Joy?
Hello. When the samples come into me, they come in its plates. We lay them out. As you can see, that's the blue paint on them. From layout, they will go to our water jet, which cuts them out. Each cut takes around a minute, where on the saw it would take over an hour. From the water jet, we bring them back over to the layout table. And they would come out as blanks here at the layout table. The blanks we then machine on a small lathe, and then we finish them on the Mazak to look like this as a tensile, and this here is a Sharpie impact. Once we put them in our tensile machine or impact, we break them, and that's the broken one. And these are broken impacts.
Hi, we're in the destructive test lab here at Elwood City Forge. Destructive testing means that we actually break apart material. And I'm here with Rachel Lucas, who's one of our metallurgists, and she's going to explain to you the correlation between heat treatment and destructive testing. Rachel?
Great. Thanks, Rose. Heat treatment is one of the most important things we do. That's where we develop what we call mechanical properties. And we need to know that our heat treatment actually works, so we have to test that somehow. So what we actually do is we take samples and we break them. So we do things like tensile samples, like this one here, and we also do what's called impact toughness, and there's a sample blank here. So tensiles test the strength of the material, or how strong it is. The impacts test how much energy it takes to break the material. So everything we do here is purposely breaking things to make sure our heat treatment works.
Okay, so now our bar has passed testing, and we're going to be turning it to clean off all of the scale that we talked about. But the first thing we have to do is what's called layout. And I'm actually going to introduce you to Mike DeDaco. He's one of our production supervisors, and he's going to go into more detail about what we do in the machine shop and how we remove all of the scale from the bars.
Okay, so what we do is we lay out every single piece that comes into the shop. What he's doing is he's checking to make sure it's not bent, to make sure that it'll make, within tolerance. He'll also go ahead and put centers in it, so that way it'll fit into a lathe at this time. Okay, so once the piece is past test, the piece is laid out in our layout department, and once it's laid out, it's ready to go in our lathe, as you see here. So what we'll do is we have a sketch provided by the customer, and the lathe operator, this is a CNC machine. What they'll do is they'll start as rough forging, and they'll just skim cut it, qualify the piece. Once it's qualified, they'll go ahead and they'll take it down to rough turn size or skim cut, depending on whatever the needs are at that time. Okay, so it's been laid out. Now it goes into one of our lathes. This one here is actually a CNC lathe, and what they'll do is they'll take and they'll turn it all down to a finished size, whether it's a skim cut size for heat treat, or a rough turn for the customer as a finished product.
Okay, now we're in a different section of the machine shop, and the piece of equipment behind me is called a peeler, and it removes scale from the surface of bars in a different way, which is very interesting. And again, I'll turn it over to Mike and let him explain how this piece of equipment works. Mike?
Thank you, Rose. So this machine does the same process that the lathes do. However, instead of the piece spinning in this machine, the actual cutter head rotates around the actual metal. It has an 8 pieces of carbide on it. It allows us to remove more at a time. Something that will take us 16 hours out in the shop will actually take us an hour or less in here. Okay, so in this machine, the parts placed on the entry table, they'll go through the feed rollers as you see here. Right, so that watery substance you see is actually coolant. And what that does is that cools the carbide down and allows it to last longer, and actually helps cut the piece of steel. So it goes into the cutting head, and it peels all the steel off the outside edges, and it comes out the other side as a nice shiny bar. Okay, and here we have our nice shiny bar coming out the other side. It's already to tolerance. After this step, it'll just go through a UT process and a burnout, and it'll be shipped out to the customer. Okay, so we have one of our saws right here. This is one of our older saws. It'll take about 3.5 hours to make that cut. As you'll see in our next location, we actually have we call it the super saw. It'll take that 3.5 hour cut and shrink it down to a 1 hour cut, and it's automated. Okay, so now down over the hill we have a horizontal plane miller. This is the only one we have remaining here at the ECF facility. And now let's get a closer look. So what this machine does is we have a rectangle that comes in. It's forged at the press. It'll come into the shop. We'll place it on this machine. And then we have a cutter head over there that'll take and it'll shave off the outside layers, taking it down to the desired diameters. So here we have one of our horizontal milling machines. This is a CNC operated machine. And what it does is it takes one of the blocks that we mill over on the planer, and we do all the contours and all the extra work on it. And don't get too excited, kids. That's not really gold, it's just a chemical reaction. And here we have our Tegner drill, which is one of our horizontal drilling machines. What we do here is for our fluid end blocks, we go ahead and we poke the holes in at this point. This is also a CNC machine. Okay, so here we have our high-speed saw. As we've seen up above, it took 3.5 hours. This saw, actually, you can program, and it'll cut that 3.5 hours down to a 1 hour cut. You can actually program it to cut various lengths, and it'll bring it out, make a cut, move the piece out, and then reload.
Okay, so the piece of equipment we're standing in front of here is called an edge prep. So we have these blocks over here, and if you want to come in close, you can see here along the edge how it's been ground. So what happens is, after a piece is forged, it has very sharp edges. You don't want those sharp edges going into heat treat, where it goes into a furnace and then gets dunked into water. Those sharp edges will crack. So we have to prep them by grinding them out and giving them a smooth radius so it's not sharp. We used to have guys standing there and doing that by hand with a grinder, all of the 16 edges around the bar. But Elwood's always investing money in the company. So one of the things we invested in was a robotic edge prep. And we actually have robotic arms that can go all around the bar, all around the block, and grind those edges down, and actually go inside the holes as well and grind the edges on the holes. So this helps cut down time and make us more efficient. And it also protects the operator, because trying to hand grind all of those where it gets hot and you have the flashings coming off, you don't want anybody getting hurt. So this is a nice new piece of equipment the company has provided us with. Okay, so now we're standing in the NDT area. And NDT stands for non-destructive testing, which means it's the final testing that we do on the part after it's been turned. You need to have a clean, smooth surface bar. And it just means basically that we don't destroy any of the part by the types of testing that we do. So I'm going to introduce you to Dave. He's a level 3. He's a supervisor. Level 3 is the highest level that you can have to be an NDT inspector. And he's going to explain to you a couple different types of non-destructive testing that we do. Thanks, Dave.
Thanks, Rose. We use a couple methods at the Elwood City Forge to ensure that we ship a good product every time. The first thing I'm going to explain is ultrasonic testing. We use an instrument similar to you see here, and also a transducer or a sensor. So the way this works is the instrument transmits an electrical pulse to the sensor, and this sensor creates a vibration, essentially a sound wave, that when we put it on the part, the sound penetrates into the material. And when that happens, if there's a defect or something abnormal within the part, the sound will reflect back. And that sound will reflect back to this transducer. The transducer will it will change that vibration back into an electrical pulse, which goes back to the instrument. The instrument will make that into something we can see on our display. So basically what you're seeing is the thickness of the material
on the screen here. And this spike right here would represent the back surface of this material. So the great thing about ultrasonics is it allows us to scan the full volume of material. So that's why it's an essential test here at the Elwood City Forge. Okay, the other form of testing we do here at the Elwood City Forge is magnetic particle testing. We use a magnetizer that you see here. We're going to introduce about 1500 amps of current into this part and through this cable that's connected to the machine. It's going to create a magnetic field like a big electromagnet. If there's any defects within this part, they're going to light up when I spray this fluorescent particle on it, and they become visible when we look at it with a fluorescent light. So Andy, if you would go ahead and energize the part. We do this test in a darkened condition so we could see with the fluorescent light. So Andy's going to energize 1500 amps. We're going to look at this indicator that lets us know we have sufficient magnetism. When we see this form like a cross, we know that there's enough energy in that part to detect the defects. So now we know that that's good. What we would do from this point is we would just spray the surface of this part while we're energizing it and look at it with our fluorescent light and look for any sorts of lines or cracks that would indicate a defect on the surface.
Okay, so now we've reached the end of our process here. All of these bars and blocks you see are ready to be shipped. So they've passed testing and they've been machined to the customer's requirements. They come down here and they get identified. We send the customer a piece of paper, it's called a certification, which just basically tells them we've made this part to the size that you want and it's met all of the mechanical properties that you need. So you're able to come in and pick it up and use it for whatever application you're applying it to.